Okay, so I think we are live. Okay, it works. So, hello everyone. My name is Protesilaos, also known as Prot. Let me dismiss this and let me bring up Emacs. So, the idea today is to do a live stream. I had an issue with the key there. YouTube keeps changing things. So, because I don't do streams frequently, every time I do a stream, something is different and I cannot figure it out. So, they always have to make some tweaks to the interface, I guess, to keep us busy. Let me set the font to something larger so you can read it here. The idea is for me to do some programming, but if you have any questions, I am happy to reply to them. I have the chat window here on the side, and maybe I can also make it a little bit larger here, I guess. How do we do that? It's Control Plus, yes. Let's have up. Okay, I think that should be okay. So if there are any questions, I'm happy to answer them. Otherwise, I will just be programming and maybe commenting on what I'm doing, so you can follow along. The idea is for me to work on my denote-sequence package, but before I do that, I realize that I need to do something to another package of mine, the GNOME accent theme switcher. And because now I have a larger font, I need to be managing my frames a little bit differently. So I need to make a small change here because earlier this morning I published the Doric themes version 1.1, and now I have to add the new themes to the list here in this package. So I want to make some changes here. This will be very quick. We don't have to worry about it. And this is Doric Magma. And there are three more new themes that I need to add. One is here, Doric Almond. Actually, let's put it before. Doric Almond, and here we have Doric Walnut. By the way, for the purposes of the stream, let me also enable KeyCast mode. This is a package by Jonas Bernoulli, the developer of Magit, also known as Tarsius, and it's this indicator on the mode line. It's an excellent package. It shows the keys I'm typing and the command corresponding to them. Maybe I can make the frames a little bit larger like this, so that should be okay. Okay, so we have almond, walnut, magma, and the other one is coral, which is red. Let's have it here. Is it red or is it orange? I think it's red. So let's do Doric coral. Okay, so let me just do this very quickly and then we will switch to denote sequence. So yeah, let's do that. Add new Doric themes to the, what was it? This thing here. Okay, let's add this and push, and now we can get rid of this. And let's go to the denote sequence package, which is what I want to be working on this evening. Let me enlarge the frame like this, and it should be good. And let me see where is my face on the frame. Okay, it's taking up a little bit of it, but it should be okay. I don't think it will be an issue. Okay, so here is the idea, what I want to do. For those who don't know, first of all, what is the denote sequence package? Let's go here to the scratch buffer. Or actually, let's go to the denote test where I have here a directory rather, where I am testing stuff. The denote sequence package is an extension I have written for denote, which is another package of mine. And what it does is it allows you to rename or name files using a file naming scheme that includes sequences, such as what you see here, 1, and then 1A and 1B. And the idea with these sequences is that then you can have a hierarchical view of your nodes. So this is DRED, the standard file manager of Emacs. And here you don't really have a hierarchical view. Here you have them on the basis of the sorting you have for the LS switches that DRED uses. By default, this should be the time that the file was created. And if you want a structural view, a hierarchical view, you want to use the sequences, and then I have this new command which is in development hierarchy, view hierarchy here. This is the idea, and you get this kind of view, so you can get a sense of what you are doing with your files. And here, of course, you can select the file and open it, that sort of thing. It doesn't really matter. It's for people who use the Zettelkasten system, specifically what is known as Folgezettel, which is basically sequence nodes. So it's a system that Niklas Luhmann had, the author of the Zettelkasten system. And if you are using that, then this makes sense. This package makes sense. If you don't really need that, then of course you don't need the extension. Me, I don't really need the sequence nodes. I am developing the package, but I don't really need it. So here is what I want to do. Right now, we have two types of sequence schemes. So let's say number one, number two, number three. These are parent files, parent nodes in your knowledge base. And if you want to have a child of one, the first child of one would be one and then one. And if you have a child of one, it would be one, 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 that sort of thing. So then if you have, oh, not this, so a sibling of one is one, two. And then you get the idea of how this is. This is the one sequence scheme. The other sequence scheme, this we call the numeric. So this is the numeric. The other is the alphanumeric, like this. And here we use an alternating scheme of number, letter, and so on. And this denotes levels of depth. So, and of course, denotes here is no pun intended. So, for example, here we have 3 levels, okay? So we have each level demarcated by the equals sign. So this is the parent, the child, the grandchild, that sort of thing. And here again, we have 3 levels, same idea, okay? But the difference is that this is more compact, and some people may like it more. The problem with this is that if you have very long sequences, so imagine a sequence, I will just do an example, that is, I don't know, something like this, okay? Something like here. Now, if you have something like this, it starts to look weird. It's something that you can not really keep a track of. So what we could have is a new sequencing scheme, which is a slight variation on the alphanumeric scheme. Namely, it will be like this. So if I take this, it will be like this. So we will have um, like the parent here will always be demarcated, and then every third level we will introduce another demarcation character, and so we will have sequences like this. Actually, it would be like this. So every 3 we will have like that, starting from the left. So the first, and then every 3. This is the idea of what I want to do. I don't know if I will be able to implement all of this during the live stream, but this is the plan. So we will start with that. And just to say, somebody here is saying, Carlitos is saying greetings from Peru. Can I make this a little bit larger? Okay. Why doesn't it wrap the text? Anyway, greetings to you, Carlitos. So let's get going. Let's go to the denote-sequence directory. And the first thing I want to do is here. I have written functions which will test, so these are predicate functions, which will test if a sequence is numeric or not. And the convention when we are writing Emacs Lisp for a predicate function is to be ending in P, dash P if it consists of many words, or just P suffix if it's one word. Think, for example, of string P, that's one word. But then we have something, and then, of course, you have a string. And then we have something like string match P, and then you have a string, okay? And this is the convention. Me personally, I don't like the first. I think it should be like this. So it's always consistent. You don't have to think about it. But anyway, this is the convention. I won't argue with this. So let's go about it. So we have these two functions, which are predicate functions. They take a sequence, which is a string, and they check if this string does what it is supposed to do. So before I introduce a new scheme, I need to make sure that these actually do what I think they do. So I have some tests, which I will come to here. So there is a built-in unit testing framework into Emacs called ERT, and I am using it here. And okay, let me tell you a little bit about this, what you see here. The DST here is a prefix which expands into this. And this is called shorthands. And I am mentioning it in the commentary here. So you can read about it by evaluating this. It takes you to the manual. And the idea with shortcuts is that you can write a very long symbol for your functions and variables, but express it in a compact form. Me, I don't like this for my actual code because then you cannot grep this thing. But for tests, which I don't need to check if I am not actually testing, then I think here it's fine. So let's go here and define a test, a def test. And DST here stands for denote-sequence tests. And then what I want to do, let's go to, by the way, I need to make some changes here. I was doing some tests and I will need to change what I'm doing to my switching of the buffers. So I want to do tests for both of these, right? So this is alphanumeric and this is numeric. Okay. So let's do first here, this one. Test that the thing does what it is supposed to. Okay, you don't really need a docstring here, but that's the idea anyway. And here, of course, we will, we will, of course, handle this, but let's come here. Okay, let's leave the other one and let's come here. So should is the keyword we are using. And here is, or rather, let's start with should not, which means that it should return nil. So if I do denote sequence numeric p, and I do something like this, I can check it here, Control X, Control E, it says nil. So should not means that it should be nil. So it should not be non-nil. It should not be true. Okay, so I can do like that. I can do like this. I can do like this. And these are the conditions where it shouldn't be true. Of course, if it's like a random string, that also applies, right? But I can have that as well. But this will not happen in actuality, but I can have it there. So then let's check what the should be. So one is true. And we can have, let me see, if I do it like this, it returns one as well. I will actually make sure that the return value is also one, because the return value matters, because I might be using it elsewhere. So if I have this 1, 1, then let's have it up. Let's have it like this. Okay, so should is the function returning an error at any point? I don't remember. I think we don't return an error. We just return a sequence or nil. So that's good. And let's see what we have done with this one. I will evaluate this buffer. And now I will do Emacs ERT. And of course, I can pass T for all the tests, but I don't really need that. What I want is this one. And by the way, what I was telling you earlier with the shortcuts, this is the actual symbol, right? Which is very long. So of course you use DST there and you are good to go. So let's evaluate. And it returns green. Basically, we didn't see anything breaking. So actually, let me do an error so that we can see how that looks. let's see. And here is the error, right? So this is the scenario where we didn't get what we expected to get. And it is telling us it should, like this should be equal to A, right? Ta, 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 and it didn't return that. So that's your error, it is telling us. So this is why we want to have many should or should not statements. These specific functions do not return error. Otherwise, I could have something like should error, like this. And then, of course, what is the condition that is erroneous? I don't need it here. So this, I think, is sufficient. I think we don't need something else here. Um, let's do the same for alphanumeric, but before I do that, let me check the stream because I noticed some comments. Denote-sequence asks concurso here, in which state of development is denote-sequence? It seems quite complete. It is complete in the sense that it is perfectly usable. Of course, it can be extended. One of the features I have added for this development version, which I hope to publish, I don't know, maybe the end of March or sometime in April, includes this hierarchical view that I demonstrated earlier. Actually, I previewed, I didn't really demonstrate, I didn't really talk about. But it includes that as well as a few other things. The latest version of Denote also includes new features. Generally, there is always something going on, but the packages should be usable. Like, I don't generally release a package that is in a not usable state. I want it to at least work for what it is supposed to do. And then, of course, it can have more features. For example, Denote, like the main package that we are building on top of, was usable the first day I published it for what it was supposed to do, like the use case I had. Ever since, we have added all sorts of features that are really refinements or power user meant or power user targeted improvements. So the original video I did for Denote in 2022 is still relevant because the package essentially still does the same thing, only it has a lot of extras under the hood for those who need them. And for those who don't need them, they can still use the original set of features. So there is that. Let's check here. Raul says spontaneous defines prod style. I like it. Thank you very much. Nikos Sterniotis says hello from Ireland, and Kalispera. Of course, Nikos, that's a Greek name. So Kalispera to you as well. And then Hammerhead Lemon says hi. Great to see a live stream. Thank you. And Raul says he will watch the recorded stream later. Very good, very good. So let's continue. Same idea, what we did here for the alphanumeric one. And actually, I could copy this because I can use the same structure. So an alphanumeric should not be something like this. It should not be something like this. And it should not be something like hello. This is correct, though, because an alphanumeric starts with a number. So, of course, if you have a sequence which is just a number, that is still an alphanumeric sequence. So, of course, we have some ambiguity, right? So this is true. This is also true. This is not true, though. Then you have to have this. So this is the idea, and I think this is again exhaustive. Of course, I will always check later, but I think for the purposes of the live stream, this is good. Let's check here what is happening. MXERT and then the name of this test, and failed. So should not. What did we do here? Of course, because this is the numeric, right? So this should be the alphanumeric. Alphanumeric. Okay, so I was using the wrong predicate function. Let's try again. And here now it has passed the test and we are good to go. Of course, I can do MXERT and then T for all the tests, but I don't need to do that right now. So I have defined tests for my existing numeric and alphanumeric schemes. So I will commit this first. So let me see, it didn't do anything else. Yes. write tests for numeric and alphanumeric predicate functions. Okay, so we have that. Now, what we need to do is define an extra test for the new scheme, which I will call alphanumeric delimited. So there will be a function called delimited p, which I will implement. And actually, I needed to change this everywhere. So it should be delimited like this. And of course, this doesn't exist yet, but I can go to the scratch buffer and just define here something as a placeholder. It takes a sequence and it does nothing. Okay, so we have that and we will return to this. So the delimited, this is delimited, so but it shouldn't be like this. No, actually, this is not delimited. This is not delimited. This is not delimited. Let me think. This is not delimited as well. And I think we are good. And yeah, so we are good. I can actually add more tests. So it could be like this is not delimited. And then by extension, this is, and maybe we can have more tests. This is, no, this is not actually. A1B. This is A1B. And we can have then another test, which is 2A1. Let's do like that. Okay, and then, of course, it's like this. I haven't yet decided if I want my predicate functions to return the string. So I don't know if I want to be testing for string equality. It does no harm to have it here, though, so I will leave it like this. Let me see. Let me just check. Okay, so this will be wrong, of course. And then what else would be wrong? Let's have it like this. It's this. This is also wrong because it has to be 3 after here. Okay, so we have the test. This is the idea. We now have to implement the predicate function, which is a little bit more involved. Oh, sorry. Let's come to the bottom and take what we have here and go to the sequence.el. And let's come here. So we want to implement the new predicate function. This predicate function now is more busy than the others. The others simply check for basic stuff. So this one has to do a bit more work. Somebody says the edge case where it is 0. So I haven't decided what I want to do with 0, actually. So right now, the code doesn't return 0. And there is the possibility that we could have 0 for someone that needs to reparent their sequences. But I haven't decided what to do with that. For now, 0 doesn't exist in the sequences. But if it does exist, then of course it will break the concept of the alphanumeric. No, actually it wouldn't, because it would be the same case as this one, right? So if it was just 0. But I have to think about it, because right now 0 we don't have, but it is indeed something to consider. And this was a point made by Technomag, by the way. So let's get to work here. So we have this. Now, okay, so these here define regular expressions. So they also check for regular expressions. I am not sure I need it for the alphanumeric delimited, but I will put it here nevertheless. A pattern for an alphanumeric delimited sequence, which should be like the alpha sequence. No, actually, I think the regular expression here is not really helpful. So it should be, it should be like this, maybe. It should have that. Yeah, I'm not sure that we will need this. I'm not sure we need this, but I will have it for now. And we will see if we actually want it. So the idea, I think we don't want it. I think we don't need it, but let me check that. Okay, so the sequence can, of course, be just a number. So we can check that. If a string match p, um, then string match p is the check for a regular expression. And I will do, if it's just numbers, basically, this is what I am saying here. And the way this is written in Emacs Lisp, the start of the string, this is what it means, the start of the string, starts, of course, with numbers, one or more numbers, 0 through 9, and ends with numbers, okay? So if it's just numbers, then, of course, we just return the sequence. So we just return the sequence. This is this scenario over here. Same idea if we have numbers, only numbers, and that thing. So, of course, I will actually do an OR here. So these are the same scenario. So let's have it there. So those two just return the sequence. So basically, this is the numeric. This is the same as the numeric sequence. It only has numbers and then no. As I'm saying this is not correct because this is an incomplete sequence. It would have to be followed by, okay, so that's good. It would have to be followed by alphanumeric characters, sorry, alpha characters, and then more numeric characters with another thing. Okay, so let's have it like that. So that's the scenario where it's just a number, and that's very clear, very easy. Uh, we want to check now. If not, or maybe I could just do the alphanumeric. If it's alphanumeric, so of course here I could actually do that if it is numeric. Let me see. Yeah. Okay. Actually, let's do it like if it is numeric, denote sequence numeric p, the sequence, then return the sequence, which you don't even need. So you can have it like this. And let's do the alphanumeric. Of course, in the future, I might think of something more efficient, but now to me, this makes sense. And we are in the scenario where it is not numeric, it is not alphanumeric, so it might be alphanumeric delimited. So here we have to do some extra work because of how we do the delimiters. So let's take a step back. We have somewhere, we have to be breaking the string. So the string has to have the string match p of the sequence has to have, sorry, this here. So the sequence we are checking has to have the equal sign. If it doesn't have the equal sign, then we are not matching something right. So it has to have the equal sign. Then I will say the components. I will call it the components, where what I will do is I will take the string and I will split it at where the equal sign is. And if there are any empty strings or whatever, I want to remove them. There shouldn't be, but I want to remove them anyway. So I have done that, which should give me now something like a list of strings. We can actually test it here. So we can have actually this test here. Let the sequence be this. Oh, sorry, it should be here. So let this be the sequence. And let's see what this returns. So it should return something like this, okay? So we will see, but thinking about this now, I think we should split because, of course, if we return this, then, of course, these should be, it should be 3. We have to check that it is 3 and then 3, but we also have to check that it is alternating so that it is like this. But I'm not sure I want this now. So there has to be a check for the thirds. It has to be like, so we have to check, okay, it's 1, then it's 3, then it's another 3. But this I'm not sure I want actually. I want to have a likelihood of this being true for the time being. So I will ignore that. I will ignore that and I will check for the, so we have the split and I want to go through each string and check it. But let me think 1 second. So the last scheme will be nil. So I will be going through the strings. So do list for every component in the components. So the components are the components of this list that we are splitting. So the strings for each string in strings, basically. What I want to do is check what it is. So the first string has to be of length 1 and it has to be a number. So maybe I can check. So here I will do unless the first, then let me think 1 second. So unless the first, when string match p, so when the first is a number, it has to be a number of exactly one number, but it has to be, sorry, exactly one, no, that's not right. It has to be length of, let me think. It could be, of course, a big number. So it's fine like that. It's fine like this. Let's leave it. And I will think about the splitting. So here we won't do the splitting. So it is one or more numbers of the for the component here. So when that is true, let's do. So the first now is true. We went through the first, and the last scheme, I will call it number, or let's say numeric. Let's use the same. Okay, so this is the first scenario where we do the first thing. And for every other, we want to go through them and check what they are. So we will do a condition here. And let me think how best to do this. Of course, it could be, no, it has to be a cond. Let's dismiss the other one. We don't need it right now. So let's see. So we will have the first, we say it's numeric. So the second has to be alphanumeric. But for each of those, we would have to be splitting them ideally. But I will think of that a bit later. Let's do a simple one here. So the first is numeric. And then, of course, we will be going through the second one. When the last scheme, sorry, we go through this. So we should, wait. This shouldn't be here. This should be here. And when, so wait. Let me think a little bit. So let's do an if. So let's have it so like this. So if it's first and we have this, so if we have this, let's have it so that it does this. So it will do that. Otherwise, we are in the scenario where we are not the first, so it's not doing what it has to do. So we are in the scenario where we are in the subsequent components. And what I would want to do for those is to check what they are, each of them, what it is. So the component I want to check now, string match p. And maybe now it makes sense to have that regex I was talking about earlier. Denote-sequence alphanumeric delimited regex. Okay, but no, this is not right because it doesn't have the equal sign, so that will never match. So each of those should be split now, because each of those now has to be a scheme in its own right. So what I want to do is I have a denote sequence split. Okay. So I have a split. I know that now each of those components has to be a sequence in its own right. So for example, if I do something like this, A1 up okay. So actually that doesn't work. So split, but there is an option for partial. Yes, okay. So it has to be partial. What? Why? Oh, this should have worked. This node sequence P. Oh, okay. So I will check why this doesn't work, because this is an error, of course, because we are doing a partial check. So it should. But okay. Let me do 1 second. Let's do an edebug. Did I not do an edebug? And by the way, folks, because I leave the parentheses open like this is why I don't use paredit, because otherwise everything would be broken. Oh, why am I not able to do edebug? Okay, so I have that. Oh, so is this not doing? Oh, so it's something else that is going on. Edebug remove instrumentation. So yeah, this I wasn't expecting. So let's see, what do we have here? What is it doing? What is the node sequence and the scheme P? So this produces the error. So of course, that was what was throwing me off. And scheme P. Okay. Okay, so we have this. And okay, so let me go now to where I was here. So this we say doesn't work, but let me actually debug. So I want to be here. Let's see what happens. Okay. It is partial. Oh, that didn't work. Okay, so our error is here. So it doesn't understand the partial sequence like A1. So our error is there. Okay, I will check what to do with that. Alpha partial. Why is it not showing me here? Okay, so okay, this is partial. So we say it has either alpha, okay, or it has, ooh, it doesn't have that. So we are checking for, okay, so we have to split it further. So this splitting doesn't work. We have to split it character by character. Okay, so, and maybe that's better actually. So using the sequence split here doesn't work. So I have to split it character by character. So individual levels. Though technically this is not right. So actually I have to fix it here. So I will do another split string, the component, the components, I want to split them like that, and again, omit the nulls. I want to split them at the empty string. So what I want to check, no, this is not right. What I'm doing here is not right, because I cannot check for alternating. Because if you have something like this, for example, so you have 1 and then A11, that's totally legitimate, because this is the 11th child of A. So that would be totally right. So it's not really 3. It should be 3 levels of depth. So it's not 3 characters. It's 3 levels of depth here. 1, 2, this is 2, and 3. So That is not right. So I really need to fix this other function. I really need to fix this. So it should be able to perform that splitting there. So let's just balance the parentheses here and go fetch that. Let's come here. So for this, we have to go to the helper functions that we have for the splitting, and it's specifically here. So do I have a test for this? And I think the answer is no. Tests. Do I have a test? The answer is no. So of course, that's a good case to have a test, but let's see first what we have here. So if I do something like A, it returns true. If I do something here like 1, it should return true as well. No. Huh. Okay, so this is not desirable. Of course, I have to review why I even have this. But this is not desirable because it should be here. It's checking that it doesn't match. Oh, we specifically don't want to match numbers here. So we are checking for one level of depth at a time. That's why. And then, of course, if you are checking for one level of depth, you will be checking for something like this, which is part of a sequence like A, B, B, or whatever, and then 2. So then that would be okay. But, okay. So then we don't want this anymore. What we should have here, so we should have a custom splitting. We really need a custom splitting, and it has to be embedded in this. So of course the numeric is already more complex, the kind of splitting we do here, because it goes through the alternating. It does, so it searches for the regular expression and it matches that, and then it splits it there. And okay, so maybe I need the regular expression after all. Yeah, this is a tricky thing, right? So this is a tricky thing because, okay, let's actually do some checks with that regular expression. So I have the alphanumeric delimited regex. So let's have here a sequence. Let's do some tests. And actually, what I was doing here is actually good. So for now, let's do the match P. I don't really care about the match data. So that in sequence. Okay, what does this do? Okay, I didn't evaluate. Okay, so this matches. Okay, what about if we have a scenario? So that one matches. What about if we have a scenario like this? It still matches. What if we have a scenario now like, so this should match, but what about this? So now that should be wrong, of course, but this matches. Technically, the regular expression works, but the limiting of 3 doesn't work. So I think that the limiting of 3, we cannot have it in the regular expression alone. The regular expression is correct, but then we need to check, once we have something like this, if it splits into 3. So, or if it splits into 2, and that we do by alternating between letters and numbers. So, okay, so we have, this means that this might be correct. It doesn't mean that it is correct. This means that it might be correct. So we do the splitting. So let's do the alphanumeric splitting here. So alphanumeric delimited, like this. And then I think what it is doing there is fine. So it has to be similar to the above. And what we want to do now, this is the idea. somebody is already giving me the answer. That's the good thing with regular expressions and doing them live. Let me see. Let me put this in my Emacs. So, of course, thank you for sharing. Um, of course, I could write a regular expression that expects this to be 3, but I don't think that would be correct. So, let's see. So, validate. Okay, so A to Z one or more times, followed by this one or more times, followed by this with 0 or more. Okay, seems right. Yeah, seems right. Um, but this is for a partial. This is for a partial, right? So this is for the partial one, yeah, not the complete. So this looks right, and then we need to check if that is 3. So of course we need to check if that is going to do the right thing. Okay, let's see. Let me remind myself of what I was doing here. Um, I'm searching for a regular expression, and I am using string match. By the way, I think it's getting darker. Let me switch on the lights. Sorry about this, because I'm not looking at myself now, so I don't know how it is. So here we do string match. The difference between string match and string match P is that this one modifies the match data, meaning that what you match, it stores the data. So then you can extract from it a regular expression group or the whole thing or the position in the buffer, depending on what you are doing. So here I am doing a string match for a regular expression over this thing, and I always have an index. So this is the 0, the beginning of the string, and then the index, I will be changing it. So this is a while loop, so of course it's like go to 0, then go to 1, go to 2, etc. And what I am doing is the first regular expression group that I am matching, I am storing it, and everything else I am not storing it. So of course I have to see what this is doing, what this is like. Sorry. So the first means this. Um, and we are pushing. So if there is a number, we are pushing it. Why? So of course we are always pushing the number, but this may not exist because it has the question mark at the end. So, oh, sorry, I'm looking at the wrong thing. Sorry, I mean to be looking at this. So again, same idea. We're always pushing the number, but we are not always pushing this because maybe it doesn't exist. So we check if it exists, and then we are pushing that into the strings. So we are collecting the strings individually. And then, of course, we increment the start position. Okay. Okay, so we have a scenario where this will always match, but this may not match. I think this is actually wrong. If we are doing if we are doing a partial match, I think this is wrong. If we are doing a complete match, it will always start with a number, yes. So this is correct for a complete match, this idea here, because the number will always exist. The alphanumeric component may not exist. So the first part here is always correct. But if we are doing a partial one, which is the test we want to do now, this fails because the first thing may not exist. So pushing unconditionally the first thing is wrong. And this is our problem here, because what we want to do is split partial components. So I will abort this here. I won't make this change here. And instead, what I will do is I will add a fix me here, because I don't think this actually works. I think this does not actually work with all sort of uh, partial sequences. So I want to fix that. Okay, so I have to fix that. Now, what I could do here, we see, okay, this we have here. Maybe this regular expression ultimately is not helpful, but let's come to what we are doing here. So what I will be doing here is a simpler split. So we have a component, which may be something like 1a, and I want to have, let's go to the scratch. So we will have something like, sorry, A1, okay? So we will have something like A1, and it should split string at the alternating point. So of course we cannot rely on split string. We should, or we can actually do the following. This is my idea now. So split string 1a at the empty thing, okay? So omit the nulls. So this means give me this, okay? And then in a loop, I can check what was the last. Let the last be nil, okay? Or let the last be, yeah, let's let it be nil. So then what I will do, let's do a do list, and let the components be nil. And then what I will do here is for every component in, now I will just do it like this, a and 1, like here. So for every component in a and 1, I want you to check if string match p. So it, because it's 1 now, it's always 1, I can be just checking for this. If it is a number like this, the component, then I want, oh, sorry, I want to do set q, the last is numeric. Of course, I will have it. So of course we will need to check. Wait, so this is numeric. So we say, okay, this is, but before we do that, we will say the current. Let's have it the current. So, okay, so the current is numeric. Okay, so the current is numeric. We know as much. And then we want to say, let's see here. When the last exists and equal the current to the last, so what we want to do, so we got a number, right? And if the last thing was also a number, what we want to do is to join the numbers. So we should, of course, this means we should also store the number. So let's tweak it a little bit. So last type, current type, last string, like this. Okay, so we have the last type, and then type. So of course, this is mostly for us to have a situation here where we can actually reliably get what we want to get. So I will actually add more numbers. Okay, so we are in a situation like this, and we can have then a B. Okay, and then we can have a 1, and then we can have an A and a B, because I want to test it with all of these. Okay, so the current type, we will say, is numeric. Okay, so if what we are matching is numeric, we say the current thing is numeric. If the last type, we don't actually need this. If the last type is equal to the current type, that what we want to do is, so of course we haven't set that, we want to concatenate the component with the last, I will call it component. Of course, I have to be storing that. So let's see. Last component. So of course I haven't stored it. If it is like this, of course here I haven't stored it yet. So it has to be like that. And then this, I have to push it to the, um, let's give it the result. Let's call it like this. I have to push this to the result. The result. Okay? This is the idea. I don't have yet the last component, so I have to think about this. So when do we do the last component? So if they are the same, which means if they are not the same, um, if they are not the same, do we just add the last component to the component? Let me think about this. Okay, we have that scenario. Okay, maybe this then doesn't make sense because we wanted to check. Okay, we assume that if it's not this, then it's A to Z. So we don't even need to check that. If it's not this, then what we have is the alpha scenario. Okay, and the current type, wait, let's see. So we did this here, and then we need to set the last type to numeric. Okay, so it's this scenario. So yeah, if the current type is the same as the last type, then we concatenated them. Otherwise, we are in this scenario and we want to set this to the alpha type. Okay, so if this didn't match, then wait, how would this be possible? If the current type, because this was a number, no, okay, that's fine. This should never be here, right? Because if this was not a number, we would never end up here. Yeah, of course. So we would never end up here because if this was A, we would go straight to here. So I think I am repeating myself here. So yeah, let's see how we will do this. So current type. Of course, there is comments in the chat. So let's actually read a little bit of these. Hello from China. It's super challenging to speak out loud while coding. It is, but what can we do? The group extracting here is a bit difficult as you have odd repeating groups. That's why validating and extracting with two different regular expressions. And maybe you have a more clear understanding of it given what you showed me, but I don't quite get it now. But with some state keeping logic, of course, can solve it with eLisp and looping too. Yes, this is what I am trying to do now, but of course I am repeating myself. We will see what we will do. Greetings from Norway. Greetings to you too from the mountains of Cyprus. Let's see, what else do we have? A nice update to the Doric themes. Thank you. Keep going, Prod. Thanks. It's super challenging to speak out loud while coding. Not really if you focus like that. So yeah, let's try. Let's see. Hopefully I can do it. But it's proving to be a challenge. So we will see. Let's do it like this. So if we match the number, then we definitely we know that the current thing is numeric. That's for sure. Then what do we test here? If the last thing was numeric, okay, so we need to do this. If the last thing was numeric, okay, here. If the last thing was numeric and the current thing is numeric, then we want to join them together. Otherwise, we want to do the following. Wait, 1 second. The last component, I didn't check. So I want to push the component to the result and then set Q the last component to the component. This is the idea. Okay. If it is, of course, we will check. Maybe this is completely wrong, but we will check. So if we didn't match numbers, then we are in the scenario where this is alphanumeric. And actually, this condition here belongs below. So we have an if here, which does this, okay? And maybe now this makes sense. So if what we are matching now is a number, set the current type to numeric. Otherwise, the current type is alphanumeric. And if the current type is the same as the last type, join them together and check that the last type. Uh, no, this is not right now. Wait. So if the current type is the same as the last type, so here we have to have an alternation. So maybe we don't do this here and we just do it. Okay, so this makes sense. So if the current type is the same as the last type, join them together. Otherwise, just push it to the results and set what the last component was and what the last type was. But these have to be done outside. So set Q, the last type, to the current type, and the last component to the current component. Okay, like this. Let's see, is this making sense? Let's see what happened. Nil, of course, because I didn't return result. And then, of course, we need to do n reverse the result. N reverse here means destroy that list and just return a new list. So let's see what happened. Given this, so of course it's not right because we have A, then we have 1, then we have 11, whereas we should just have 11. Then we have B, that's right. Then we have 1. Then we have A, which is wrong. And then we have BA. So for this to be correct, we have to have this. This is what we are working towards. If we get this, then it is looking right to me. We got this now, which is wrong. And this is wrong because why? So concat the component to the last component, which is itself. Let me actually change the numbers here so that it's easier to also do this. And let's have here C, okay, and let's have here 3, okay, like this, and put a D here. Okay, so we get one thing. It's a number or it's a letter. That's the idea. If the last type is the same as the current type, then, of course, here we assume that we have, but the last type starts out nil. So in the first case, this will not be a problem anyway, but we will check. Okay. And otherwise, we say, I don't see the error, obviously, now. So here, concatenate the component with the last component. Okay, let's have it like this. So here we see clearly the mistake. So we see clearly what I was telling you earlier. So now what we want to do is make sure that this is not happening. So what I will do now is debug it. So let's call it a test and let's pass the sequence now. Or it's the split sequence, okay? But we will have it there, don't worry. Sequence split like this. So I want to turn this into a function. And the reason I want to do that is so that I can do this. So what I will do here is Control U, Control Meta X. So now I am debugging it. So I am stepping through it. This is the idea. And what I will do now is type N to go to the next thing. And we are now in the do list. So our first thing is the alpha. It's not a number. Therefore, it is the alpha type. The current type is not the same as the last type. So just put that in the result. Okay, that's good so far. The last type we say is the current type. The last component is the current component. So far, so good. Now we are matching 1, which is numeric. And we say that the current type is equal to the last type. The answer is no, which is good. Okay, So, of course, we shouldn't be pushing directly. We should just be adding it to the last component and then the next time pushing it. So maybe I can rewrite it like this. Okay, so when it is like that, do this and set the last component to the component. So here I will say, no. The last component will exist, of course. It's tricky, folks. It's tricky. Or I could. Let me think a little bit here. If we have. Because of course, if I don't push it the first time around the loop, I have to store it. But if I store it, then the next time I go through the loop, I have to push it here at this point. Okay, so let's actually do it and see what happens. Let me rewrite, though, this function. So let's leave it like that. And let's rewrite it. So let's have a when here. So we are in the scenario where if we are to concatenate, we concatenate. If we didn't concatenate, though, actually, I will put the when back. No, actually leave it there. I want this to happen. And then the next time here at this point, okay, I have to think. Because this is wrong. What I'm thinking is wrong, the way I'm approaching this here. Because we go through the loop, and the first time we don't necessarily push. That's the idea. We have to defer it until the next time. And the next time we will only push if the thing is not of the same type. So it's here where we will push. But we will have to do it with the last. So here we have to push the last component onto the result if that component exists. So let's do it here. And then last component. And then do that. Okay, let's see if this does anything. So let's see. Let's take this. And almost. This is already better, but it got wrong the order here. So it has to do with this concat here. Let's see. Oh, this is a thing of beauty now. Is it? No, it's wrong. It's wrong. I am celebrating too early, folks, because 1 and 2, then we shouldn't have a 2. But of course, what I'm saying now is wrong because we could have like 3 numbers. So basically, the approach here assumes that they are 2 numbers. So this is not going to be right. We have to be collecting them into a list until we have a change and then push. So the last component is not right. It doesn't work like that. It should be last components, same type. It should be like that. And here, instead of a Q, it should be this. It should be the component to the last components of the same type. Let me now think a little bit better about this. So we have the scenario where they are the same type, what we had before with what we have now. And if they are the same type, we may not be pushing. If they are the same type, we actually do this. If they are the same time, we actually do this. The joining here will be done. So if they are not the same type, so it's not the same, then what we do, string join the n reverse of those onto the result. So all of those that we collected, now we put them to the result. And here, let's think here 1 second. So if it is the same type or if it is not the same type, I think there is no other condition. So I can reduce this to an if here. Okay, so we have this if. Okay, so we are pushing onto, let's see. So if they are the same type, push them onto the list, which we will use later. And if they are not the same type, it's time to use that list. Okay, so if we pushed onto that list, then what we want is this list to be reset. Okay, that's the idea. And the last type is the current type. And okay, I think this does it. Let me see. Let's check. So that's what we got earlier. Of course, this is completely wrong. It's completely wrong. Oh, but I'm curious why it did this. So of course I have to read the code carefully. So I think this part is solid. So let's create some space. So this part is solid here. Let's see what we have here. The current type is the same as the last type. If it is, then just increment this list, add to this list. If it is not, then it's time to take this list and join them together into one string and then put that in the result. And then reset that list. What do we have here? Of course, they may not be, this may not exist. So I need to do it like a cond. So here. Okay, so we have this. If this exists, then push it onto the list and make it nil. If it doesn't exist, which is our final check, then just push. Let's just push the component onto the result. Is that the thing? Component onto the result. And then set the last. Okay, let's see what we did here, folks. So, no. Of course, now this is completely inconsistent. So this is totally wrong again. So yeah, let's see what we have. So the current type is equal to the last type. So if that is the case, just take what we now have, what we are now checking, and add it to the list. Or actually, I will now do the edebug because now it makes sense. Let's see. So this is A. So that's alpha. Alpha equal to nil, of course, is nil. So do we have anything there before? We don't have anything there. So we just push alpha onto the result. To me, this looks fine. Let's continue. We say now that the last type is the alpha type. Now we are matching a number. So we say that it is now a numeric type. So the numeric, of course, is not equal to the alpha. But here is exactly the problem. We should never be pushing. We should never be pushing. I abort. We should never be doing this because, of course, we don't know what follows. So the if that I have here earlier was actually better. So it is here. Okay, and then I will debug this. We got here earlier the wrong result again, but I want to understand what I'm doing wrong because I think this is the right approach. So I saw some comments, folks, and I'm coming to see here. But for me, by the way, this is very fun because I am now figuring it out as I go, and for me, that's part of the fun. If I already knew about it, or if I got it, from the internet or something, it wouldn't be fun anymore. Let's see. So, of course, here we shouldn't be pushing an empty string. Okay. Okay, so no. So, of course, we should always be pushing. Okay, so here it is. We should always be pushing the component onto the things. If it is that, then this. Otherwise, just push. Um, no, I don't like this because now it's always a list. So this will always be a list. So we're pushing a list onto that. So maybe we want to do a string join. Sorry, a string join of that. Okay. Let's see. Let's see what we did here. Of course, that makes no sense. That's still wrong. Oh, it's a very interesting problem. I wasn't expecting it to be this tricky. But let me read some comments. So, of course, you see me fail miserably here, and that's great. I love it. Let's see. Where did we stop? Technomag, by the way, you posted a comment, and it seems to be trimmed. You have a sample with your regular expressions, but I don't see it in the comment. Maybe because of all the escape sequences and whatnot. Colonial P says, hello, Prot. Hope you are well. I am fine. Thank you very much. I hope you are fine too. Let's see here. Hats off to Prot's English skills as well as English skills. I wish I could also do live streams like that someday. It's a matter of practice, of course, but you can always try in private. Like, you don't have to go live. Like, have somewhere a camera that records you and start talking, and then hear yourself back and see how that is. Same idea if you are coding, have a camera and program something and see how that looks, and then try to combine the two. But at least for me, you will notice here that I am failing. I'm not actually making any progress, right? Um, so in a sense, you could say, oh, this is embarrassing, right? So I don't want to be embarrassed in public. But for me, this doesn't feel embarrassing because it's part of the process of learning, and not just learning because maybe I know the code or the concepts or whatnot, but of understanding better what I want to do. So fleshing out that which is not yet clear. So I think with practice, you improve, but eventually you will never be perfect. So at some point, you just have to go live or try and hope for the best. And people generally will not judge you if you make mistakes because everybody makes mistakes, so long as you don't pretend to be the preeminent expert or, the person who makes no mistakes. If you are not pretentious like that, I think, yeah, nobody has a problem with it. So let's see. Jan here says, very cool that you are working on this extension. This naming scheme was the reason I initially implemented my own Zettel custom package for org mode. Ah, good to know. Good to know. Of course, if your package works for you, then you can use that. There is no reason to switch to this package. But yeah, it's an interesting problem or an interesting workflow more broadly. By the way, the package works. So I am working now on a new feature for it. So the package is already useful as is. And there is a function which is called actually denote-sequence convert, I think. Convert, right? So the new sequence scheme that I hopefully will implement, you can simply convert existing nodes to that if you care about this. So there is that. But let's see, what else do we have? It's refreshing to see someone actually code and reason about it rather than vibe coding. To be honest, it is inspiring for me. So, of course, vibe coding, if it works, ultimately it's the results that matter, right? But for me, it's also a matter of, is it fun? Like, of course, I could now vibe code this and probably get something that works or maybe works and not have to go through this trouble over here. But I wouldn't, I would rather deny myself of a learning opportunity because going through the trouble here teaches me something and trains this muscle, as it were. And it's something I like. I want to stay sharp and I enjoy the process in that regard, not just the result. Let's see here. Hello, Prot. Good to see you. Is it possible to make backlinks buffer prettier like org-roam or log-seek? It looks a bit messy right now because of displaying directory path and long file names. Yes, I'm happy to improve it, but I'm not sure how log-seek does it, and I haven't checked org-roam in a very long time, so I don't remember how they do it either. But yeah, always, I'm happy to improve things. You can always open an issue on the Git repository. Maybe also post a screenshot that will help, or you can email me and send me that screenshot. Let's see. Let's see. So, yeah, Technomag says, yeah, it was eaten by YouTube here, so that's unfortunate. Um, so also it doesn't allow you to post links apparently. I actually, before the chat, I checked the settings for the moderation tools or whatever, and I said, do not hold anything. I want to see everything. And apparently it still does this, so it's out of my control. Yeah, so what can we do? Let's see here. What else do we have? Hello, people. Prot. I never knew you streamed. Now, how long have you been streaming? I am not consistent. It's infrequent. I don't even remember when was the last stream, but probably it was a few months ago. And when I do them, I enjoy them, but I am not. I don't have like a regular schedule. Maybe it's something I will do at some point because I don't know if you know this. I have written about it on my website. I have installed a new battery for my solar panel setup. So off-grid solar panels, and this means that I have electricity basically all day. And so now I can do live streams in principle. We will see. We will see. Um, Maybe I will commit to a schedule. Let's see. Hello there to you. It seems that the nReverse function was introduced in Emacs 30.1. Wasn't there any function like that one before? Um, I believe nReverse has been there for a long time. Actually, on my case, it says probably introduced at or before Emacs version 13.8, which probably was like 2 millennia ago or something. So that should be good for our purposes. But I'm not sure why you get the 30.1. So hello to you too. Let's get back to what we are doing here and what I am doing wrong, more specifically. So I have this result and I get this. So this is wrong. But now let's e-debug again and let's see what is wrong. So the first one I think is always right. Oh, wait. Push component onto the last components. Of course, for the first one, it means go through that extra step of pushing it 2 times. So at this point, the result is A. Okay, that's fine. Now we have the number one. What happens now? So this is pushed to the last component. So of course, this makes no sense again, because now we will be pushing it again to the result, whereas we shouldn't. We should wait. And of course, now I got another idea. Let's not do anything with last. Let's do no. I was about to say let's collect all the numbers together and all the letters together and then push them at the end, but that wouldn't be correct because we have to preserve the order. So maybe just flipping those. Sorry, what does this do? Ah, no. No. So, okay. Actually, the n reverse here is wrong. Let's see. 21. Where does 21 come from? Okay. But this is wrong. This is definitely wrong still. So, of course, the first one will be empty. But let's check. Oh, sorry. Sorry, I deleted too much. Let's delete this here and let's see. Okay, so I'm now debugging again. So the alpha, the first one, is right. Wait. Okay, this is wrong because we have to have here. So let's have that. Okay. And if we don't have, okay. Of course, if they are just one, when we push, and then we have that, and then, of course, this could be a cond, but I will check now. Let's see. Okay, this is wrong anyway, but let's do the cond. Let's have it here. Okay, so we have this, and in this scenario, these exist. So we want to join them together with an n reverse still. This is the part that was wrong earlier. N reverse. So this, of course, can be its own function, but let's leave it right now. If they are the same, if this exists, but they are not the same, so this is wrong. So if they are the same, if we have pushed them, no, wait. So I think we should be pushing at all times, but never to the result. We should be pushing here. So if it is the same type, then they are of the same type. This don't do. So we have collected of the same type. If they are not of the same type, let's see. So, okay, so here, if. So if they are of the same type, we want to collect them. This is the idea. Collect them all together. If they are not of the same type, but this is not right. This is not right because if we go from A to 1, then of course 1 is not of the same type. We don't want to push it right away. That's the problem here. We would want to collect it and then push it. When would we push it though? Because of course we can collect it like this, so we wouldn't need to even check for the type. Okay, so in other words, we are always collecting. If the current type is the same as the last type, we are still collecting. So we are collecting at all times. We are collecting at all times, but we should be pushing only when we have a change. Only when we have a change in the type. But the change in the type, we can only know it at the end, because if we are here and we change, now we have changed the type. We don't want to push. We want to check the next and then push. So that's not helpful here, the way I have it here. Maybe I am approaching it wrong. Where the splitting here is wrong. So let's take a step back, because this is completely wrong. The path I went down is completely wrong. So let's take again this here. Let's have this over here, and let's do a string join so that it just does the thing for me. Why didn't it do string join? Of course, because this has to be a list, sorry. So let's do concat. Okay, so we have this here. Okay, so here is the thing that we want. Oh, the dogs heard something, so they are barking, so let's not worry about that. I have to remain silent for a second. Let's see. I have to remain silent for a second because they heard something and they got all excited. Let's see. So I have that, and then I have the alpha. So maybe we go what was it called? The Technomag was trying to tell me earlier, but I didn't quite understand. So we have this 0 or more times. And basically going through this is actually the best approach. So then, okay, let's do here. Let the start be 0. Okay. And while okay, so here, and then we should have the remainder. Wait, string match the start. Let's have the start. Okay, so string match that here. So we are matching that regular expression onto this string. So first of all, does this match? It does match. And we check for the start. So if it does match, then we want to change the start to match end, I think. Or is it match beginning? Let's do match beginning. Match beginning of the whole thing we are searching for. Why can I not indent? Is there some error here? There is an extra parenthesis there. Okay, good. So we are changing the match, and then we want we want either of those, what matched, either of those to push it, basically. So then we have the strings, let's call it strings nil. Let's have it like this. So whatever it matched there, and now Technomag, I think I understand what you were trying to tell me earlier. So we can have either that or the alpha, and from the beginning. So of course, now this makes perfect sense. And we push the match string, and the match string would be of 0 actually onto the strings, and we return strings. What about this? Okay, that doesn't work. Let's see. This doesn't work because, let's see. Okay, let's see what is the error. So we start from the beginning. The match beginning of 0, that's the start. Match string of 0 is out of range. Huh. Okay, let me actually simplify this. So if I do this here, I want to do here prog n, this, and then match string of 0, meaning of the whole thing. Huh, that's out of range. So do I have to give the string? If I give the string here, let's see. Okay, that matches the thing. That's not correct. It should return the first thing. So it should return the first thing. Of course, now I have to change the regular expression so that it is this, but not the alpha. So it should be that followed by alpha. So that followed by alpha, or the alpha followed by the numbers. Let's see. Okay, that returns the alpha. So if I check now from position number 1, oh, okay, so match string 1 then. Okay, that's promising. So let me do it again. 0. Okay, that's the empty string that I don't want. It is the empty string because, of course, it's 0 here. So it has to be 1. And here, it has to be at least 1. That is the idea. Ooh. This is not right, but I like this direction. This is promising. It's an alpha, at least one alpha, followed by 0 or more numbers. It's at least one number followed by 0 or more. I don't want to I don't want to capture the alpha. That's the thing. Okay, so here it's nil. If I do 1, it's the 12. So the alpha, I'm never capturing it. So the first character here, I'm never capturing it. We will see why. So of course, maybe I can actually call these. I forget how we do it here. It's like this. So let's call this 1 and 2. And maybe we don't even need actually, like it shouldn't be necessary. And I can say if that, we can do an OR. I just want to see what it returns each time. Okay, so, oh, this is completely off because it is needing the string here for whatever reason. This I actually don't know why it is doing it. So let's have it like that. We need to pass the string as an argument here. Maybe because I'm doing it via a let like this. Okay, so if I do the 1 position, okay, this is, I think we fixed it, folks. Let's do the 2. So of course that's, okay, so it won't be 2 actually because, okay, so I think here we are. Okay, let's now take this and come here and let's refine this. So it should be the match beginning of whatever we matched. And then, so let's take this regex. So this is what we are searching. In that, with the start, set the start to the beginning of what we matched. And then, of course, we need to know what is what we matched, right? Which group did we match? But yeah, okay, let me think about this. Let's just push this onto the strings and see what it does here. Like this. Okay, let's see what does this do. So of course, string is void because I have to have here the string, and let's have it here, the string like that. Let's see. No. String p. What is this? Oh, what was the error here? What is this? Because of course we are pushing into a list string. Oh, sorry. It should be pushing into the strings. So of course that's an infinite loop. Not good. Not promising. Why would it be an infinite loop? Because could the start maybe it's the match end? No, it's the match beginning, but of course the match beginning will always be, so it has to be the end. Okay, no, so that's not right. C, B, C, D, B, and A. That's completely wrong. Why is it so wrong? And here I got the expected result. Here I did get the expected result for sure. Because of course it would be like the end. I will do it manually. So if I do string match onto this, right? I want to match this. Let me see the positions. So here it should return 0, okay? So that's correct. So if I say now match end, what is a match end? Match end of the last thing, it was 2. Okay. So now, actually leave it. Let's now do here 2. And 2 returns 2 back. So that's not correct. What about if we do this again? And then here we do match beginning. Okay, so I think it's a problem here. Okay, so now it's 1. Okay, so if we now do 1, wait, this is not what I got earlier. Here, if I do 1, this is what I get. What happened? Sorry. This is the position. This is the position in the thing. So, okay, so I have that. And if I do match string. Actually, let me do the match string 0. That's not correct. In the string here, let's see again. That's not correct. That's the 0th. So the 1 is nil. Okay, that's good. And that is also nil. Let's see. So, interesting. Huh. What is the error? So I am telling it start from the index 1. So basically start from here, basically. Of course, I could be cutting that string and just checking it from the beginning each time. But ideally, I don't have to do that. I should be... So 1 here means here. So it should match 12. But let me now do something else just to see. So if I just remove this and I do this, is it matching 0 again? And okay, if it's matching 0, what is the match string? Like, what did we match? Oh, this thing doesn't work in the buffer. So it matches 2, but not the 1. What about the number 1 regular expression? It matches nil. That's not right, huh? So, of course, I could tweak it a little bit, but let's have it here. Let's see. Oh, now it, yeah. So the match data is a little bit inconsistent. So now it's matching 12, right? So this is the correct behavior. This is what I'm expecting. And basically then it's matching 12. So what is the match end of 1? And 1 is this. Okay. So the match end, give me the match end. Match end, it doesn't take a string. Okay. So then that's the 2 position in the string, which means here. So now, like, I expect this to work now. I'm not seeing the error. So it should be this, right? And then if I do for this, that's nil. That's good. So what about the second? That's correct, what it was there. So it matches the position 1. And if I comment this out, it matches B, which is correct. So I think the code here is correct. But what is happening here? I think the code here is correct. So let's actually test with a sequence. Okay, so let's actually test. So here will be the sequence. So we don't even need that here. And let's rename the string to sequence. Okay, so let's do that, folks. Because the thing here produces an error, and we see the error again. So it should be match beginning, first of all. It shouldn't be the match end. It should be the match beginning. And this gives us an infinite loop, which is not right. But I'm curious why. Because I was expecting ultimately to just return nil. Okay, so the start is 0, and then of course the match beginning of 0 is 0. So of course we are staying at the 0th position. So let's do here. So here we have the match, but we need to know which was the match. So let's do here like let the first be nil. Oh no, wait. So one of the 2 will be the right one. And we only want that, but we want the number here to be the same. So we need to know which one was the same. So let's say here, if let the match is that, then do that, okay? Otherwise, do this. And then here, so we have it, again. So it's a little bit of repetition, but it's not a problem. So then push the match onto the strings. Otherwise, push the match string 2 onto the strings. Okay, and that closes the loop, and this is not correct. And I was about to say I fixed. Let's see what we can do. So here we have 0, and that is nil. So we go into the else clause. Okay, that stays at 0. Oh, wait. Why? Why is it? Okay, let's see. Oh, match string of 2. Does it need the string? Okay, so for whatever reason, it needs the... Okay, so that also stays at 0. So, of course, this is not right. Because match beginning... Why do I get the inconsistent results? When I did this earlier, match beginning wasn't the thing. So let me do match end. Okay, maybe this is right. Oh, let me n reverse it, and maybe this is right. N reverse. Okay. Okay. Let's see. Okay, I think this is right. Now let's test this with arbitrary things here. So I will have like more numbers here. And let's see. Okay, this is promising. Let's have more letters here. That's correct. Let's have more here. Oh, this is working, folks. So here, yeah, it's working. And let me add some more numbers here. Okay, so this is working. Okay, okay. Okay, so I fixed it in a very roundabout way. So yeah, let's see. Let me see some of the comments because, of course, we are very far away from what we were doing, folks. And I will return to that. I don't forget the context. But let me get to the comments a little bit. Hey, Prod, why did you switch to GNOME from BSPWM? The answer is that there is this app called Signal that I am using because people prefer it over email sometimes. And for whatever reason, it won't launch on BSPWM or Herbstluft WM. It keeps telling me log into GNOME so that you can have your, I don't know, the keyring, unlock your signal or whatever. And I could try to fix it, but I'm like, you know what? I need to get things done. I cannot fix a signal, but I need signal. So I have to do that. But if I fix it eventually, I will be back. So let's see. The length of the added string should be accounted for as well. Maybe yes. The way I did here doesn't need it because of this here, which is when we match something, we have the match data. And part of the match data is the position, like what did we match, in this case, in the string. So because we have that, we effectively increment the string. So we match less and less of it as we go. So basically this works now, folks. Let's see here what we have. Hello, my friend, Mr. Boal. So hello to you too, my friend. Good to see you well and consing. Yeah, of course, consing onto the cells, so that's good. Hope Maris, Elea, Atlas, and the puppies are fine too. So Maris, Elea, of course, are names of themes. Atlas is one of my dogs. The puppies, of course, the others. So yeah, thank you very much. Thank you very much, and I am glad to hear from you, and I hope you are doing well too. Let's see. Does count the added string? Yeah, I realized my misunderstanding now. Okay, that's fine. That's fine. Of course, it's not a problem. As you can see, I struggled myself. So this is good. Let's take this now and go back to what we were doing, folks, because this was like a really roundabout way to come to this part here, which is to check if the thing is delimited, is correct. So maybe I don't need to go through the components now. So I have to have it like this. So do I even need this? The components? I don't even need the components. The thing has to have, though, that. Let's see here. Strings and reverse. Okay. So let's see what we have here. By the way, somebody asked me what am I writing. I forgot to answer, I think. It's an extension for my denote-sequence package to add another sequencing scheme. And basically, what you can see is that it is not a trivial problem, or at least I didn't know how to do it well. Return sequence if it is an alphanumeric delimited sequence. If it is alphanumeric and delimited. Okay. And maybe I can say this as well. Pair the thing. Okay. So we have that. And of course, it's that. Let's see what we have with this now. So what I was doing before this, I was writing a test. And then, of course, we have to go back to our unit tests to see where we are. There is a chance that this is completely wrong, but let's go and see. Of course, it is giving me a warning here. What is the warning? Docstring. Yeah, okay, whatever. Return sequence if it is alphanumeric and delimited. Refer to the for the details. Okay, let's do it like this so nobody complains. Okay, we have something here. Now let's go to the tests, folks. So it's a very long roundabout to reach this point. So I wrote this test, and the idea is that it should return nil for those, and it should return true for those. And well, let's try and see what we did. There is a chance that this is completely wrong, but we are working towards it. So let's see. And what I want to do now is the delimited here. Okay, so we have our first error. Basically, 1A, it matches because, of course, I did it wrong. It should be not, right? It shouldn't be like that. Um, um, Wait, let me think. So, of course, it shouldn't be numeric. No, actually, it can be numeric. It cannot be No, actually, it cannot be numeric either. So, it has to be this. It has to be string match P. So, this is easy now. 0 through 9, one or more times, ending there. So if we have that, this is legitimate. Okay, let's have it here. So this is a legitimate match. This is correct. Okay. So if this is correct, then return sequence. Okay. This is correct. It should not be alphanumeric, meaning that it has to have that. So maybe we don't even need to check for that. But I will leave this out for now, or it should be um, maybe it should be this. Let's leave it like this. Let's leave it like this for now. And let's do the test and we will see. What is the error here? What is it saying? This we don't care, is not known to be defined. How? What about this? Oh, come on. It should know. Let's kill this buffer and open it again. And hopefully it makes sense of it. Okay, so now there are no warnings here. Let's see. Let's see now. Let's do the test, folks. Here. Let's see. So, okay. Test that's what it's okay. So should not. Oh, wait. That should work, actually. It returned A. Okay, let's try. So where did I say should not? Should not this? This should work. This returns A. Of course, that's wrong. But it doesn't return nil. Of course, why does it return A? It should return sequence. So it should return sequence here. And this whole part here belongs elsewhere. So I shouldn't be collecting here, but I will fix this later. So this should be another test where we do the splitting. For now, I would just want to return sequence. When all this happens and the strings are done, so for now, I will comment this out and I will return sequence. Okay, so I just want to see, because of course this test has to be more thorough. It cannot be like the others. So this doesn't work. Let's see what is the problem here. It should not. Okay. What happens if we do this? It says that it is right, which is not. So of course, here we should say here when that, maybe we can do here, and the denote sequence numeric p of the sequence like this. Okay, let's see, what does this return? So that returns nil. Okay, let's redo the test. Okay, so 1a is failing because that should match. So of course this is correct, this should match. It shouldn't be should not, it should be should. Okay, let's see what we have. Of course, this fails. So now, of course, we have to improve the test. Okay, so let's now go and improve this. So we return the strings. So we are at the point where we have returned the strings. We have collected the strings. Now, what we need to do is to make sure that they are alternating. So simply, it's numeric or it's not numeric. This is the idea. So we have all the strings. And now that we have all those as part of this let, we don't need that. We don't need to return them. What we need to do is let the last type be nil. So do list for every string in the strings, okay? Actually, reversing them is not even necessary, but actually maybe it is. Let's leave it. So if string match p, then what we have here, it should be only numbers. So we have the scenario where it's only numbers. Okay, if it's that, then set q, the last type is numeric. Okay, and then in the other scenario, it is alpha. Numeric. Okay, so we have that. So we have this, and we need to make sure that we will do a catch actually. Catch error, and we will say here. So okay, so here we do this. Wait. So the first time we are setting it, when the last type, I have to set the current type as well. So so I was doing it earlier with the last type and the current type. So the current type, okay, so we have the current type and the last type. So at this point, I am setting the current type here, like this. So I am setting the current type. And when the current type is equal to the last type, I want to throw an error and say, or actually, I don't want to throw an error. I want to exit with nil. Otherwise, if all this works, I just want to return sequence and sequence here. Okay, so if I wrote this correctly, of course, and there is a good chance, as we saw earlier, that I didn't write it correctly. So we will see. I can just evaluate this, and this returns that's wrong already. So um, this is not right because here it should alternate, which it doesn't do right now. So maybe we can take this smaller snippet and go into our Scratch buffer and see what we can do with this. So yeah, I picked the most difficult problem for a live stream, which is great. Let's see what we can do. So um, n reverse of strings. Let's take this. This is good. We don't need the n reverse of the strings here. This is good. Does it ever return an error? Invalid function A. What was that about? Ah, of course. Here, like, okay. So that returns nil because it doesn't match. Let's call this actually a test of the sequence. Okay. So, okay, let's call it strings. And let's put the strings here. And the reason I am defining it as a test is so that I can actually debug it. Okay, let's debug and let's see where we are. Okay, so we are saying this is an alpha type. Okay, if this is the same as the last type, it is not. So continue. Um, let's say, so we are now matching a number. Is the number the same as the last type? It's not, so continue. Now we are matching B. Is this the same as the last type? Of course, I'm never setting the last type, so 1 second. So that will never work, of course. Set Q, the last type, to the current type. Okay, so that returns nil. Okay, let's see, what are we missing? Okay, so let's see. So let's see. This is a number, so that's numeric. Is the numeric the same as the alpha? The answer is nil. Of course, 1 second. I think actually it works now. So if we didn't get the error as part of that, of the throw, then we can just return strings. And that returns strings. So this is now the correct. So if I now put here another alpha, it should return nil. No, that's wrong now. That's wrong. Like it should stop there. So this has to be part of the catch. It has to be in there. I wanted to, okay, this is nil. That's good. So that's nil. And if I now do this, that's the thing. Okay, so this is correct. Let's go and fix our thing. Okay, let's come to the denote sequence here. Okay, and let's see what we have here. So catch that. So this has to be in here. And here we need to be setting at the end of this, the last type is the current type. I think these are the two changes I made. So that closes the let and that closes the cond. Okay, let me now test this. Let's go to the tests here. Okay, so this should return nil here. Okay, I will just evaluate them like this. This is correct. This is correct. This actually is where we need to test for the length. So for now, this will be correct. But we need to test for the length of those, but that's an extra problem. So fix me, we need to test for length of each segment. Okay, so for now, this has to be commented out. So this should be nil, and this is correct, and this is correct, and this is correct, and this is correct. Let's actually do it. Okay, so yeah, now the test passes. So actually I will put this fix me in my code here. So here we have the fix me. Or actually, let me move it here. Here. We shouldn't be checking just for this here, but we should be checking for the length of each segment. And I will put here like this. Specifically, the first should be 1, then every other should be maximum 3, where the numbers refer to levels of depth. Okay, so not 3 as in 3 length, but 3 as in levels of depth. So, for example, I will just write it here. If we have this is 1 level of depth, 2 levels of depth, 3 levels of depth. Okay, so that's what I want to do. But I think I already did a lot already. But uh, um, let's see. What's the time? So it's 2 hours already on the clock. So I think this is a good place for me to stop, folks, rather than continue and implement this. And I can push this already into a new branch and then continue to work on this. But the idea now, the next step is that it should enforce this. It should enforce the lengths. So each component should have the right length, and then that would work. Otherwise, we will never get this right. If we don't get the correct length for each segment, then we are not doing the right thing because, of course, that test. Let's see here. Where is the test? Of course, here. Uh, this will give us true, which is not. So this should fail. This should fail, and this should be correct. This is the correct test. So we have the fix me here. So I will just say here, check fix me in the source. Okay, so I have that, and then I think this is good. Let me see the last comments. Of course, I can commit this. I will go to a feature branch. Let's create here. This I haven't used, I think. Let me see 1 second. This I haven't used, so I can remove it for now. I actually don't know if I even need those here. But for now, let's remove that. And let's commit this. Okay. Okay, so actually this was for earlier. Let me fix this here. Fix the error message of that. And I want to add another fix me for this. Add fix me for that. Okay, and now we can move to the feature branch. So let's do alphanumeric delimited scheme. Okay. Oh, sorry. What was that? I always forget that you have to say where you are starting from. I'm starting from where I am. Where would do you expect me to start from? So it's alphanumeric delimited. What happened? White space is not allowed. Okay, scheme. Okay, so let's do that, and then add work in progress sequence scheme alpha numeric delimited. So of course my dogs found some bottle somewhere and now they are making a mess of things. But anyway, I will close this now, so I will commit this and push this onto the feature branch. So that's good, and I will go check here. And let me check the comments here if there is any final comment I missed, and then I can say goodbye. Let's see where we are. Mode line you got there. So the mode line here, what are the symbols mean? Okay, so the symbols here, um, this means that it's the major mode, and what you see here, the P, it's an experiment that I was doing. So, how did this happen? Bring this out of the way. So it's an experiment that I was doing where I was creating my own so-called icons. They are not really icons. It's text and they just have some colors. So P in this case means program. These are Greek letters, by the way. So it means program. A means it's a document that it's readable. Of course, they mean something in Greek, although they are not random. If it's the bar and the asterisk, it means that it's a directory. If it's like this, what you see here, it means that it is a dot file. And you will see that everything that starts with the greater than sign, it's a file. And everything that starts with the bar, it's a directory, or basically a collection of files. So it's either a directory or an archive. This is the idea. Of course, I don't know if this is actually good, but that's what you are seeing here. So this is the so-called icon, okay? So for Direct, the icon is the directory icon. Now this refers to the branch. So this is the icon again I have for Git branches. So I am on the main branch. Actually, am I on the main branch? Is this correct? Why didn't they switch? Wait, okay. So, oh, it still says main branch. So, I haven't noticed this before. Like, it shouldn't be saying main branch. It should be saying the branch I am on. But, okay, for whatever reason, it says main. So, anyway, this should say the name of the branch I am on. It is wrong. So, I will check what is the bug there. But the icon is correct anyway. So, this should be the branch icon. This is the idea. And then otherwise, what you are seeing is, yeah, just that. I don't know if I will keep that experiment with the icons here. I was trying it for a while and I was like, okay, this is cool. So let's keep it for now and see how it goes. Anyway, that's all for today, folks. I struggled more than I would like to, but it was a good experiment. I ultimately learned. And I learned that there are also things that need to be fixed. And of course, it goes to show that um, it's not trivial. It's not trivial, of course, to implement new features. So you see, for example, a function like this, and you're like, okay, how long could it take? Well, you have to think about it. And this is a function I have had for a while, and already it's not correct. So there are things that I have to improve. And this is fine because it's a process of learning by doing, and I have a lot of fun along the way. So I will close the stream now. Thank you very much for your attention. Take care and goodbye from my side. I need to find all the relevant buttons. So I have to do here stop streaming, or do I do it first on YouTube? This I don't know because they keep changing them. Where is YouTube here? Um, Okay, I have to do end stream and then stop streaming here. Let's do end stream, or okay, let me stop streaming here